Now I'm going to show you a cool shortcut. This is not, I mean, you can solve any of these proportion problems, these triangle problems with proportion. You don't really need to use the geometric mean, but it's a neat little shortcut. And so I'm going to go ahead and draw the triangles, separate them. All right. It's not perfect. And this angle goes here. That's a right angle. This angle came from there. And that's the right angle. And if I want to, I'll just draw the original again, just to be extra sure. But since I'm looking for x, I really don't need this piece. But let's go ahead and label everything. All right. So hypotenuse first. Hypotenuse, hypotenuse, hypotenuse. Or if you did it up here, I like it even better up there. All right. Then you pick a leg for this one arc mark. There's a leg for the one arc mark, right? You color the other leg that's touching the two arc marks. That's the leg touching the two arc marks. And then you color in the missing color. All right? And I forgot to label. This is x, that's x. This is 32, that's 2. All right. So I'm trying to solve for x, so I need either green or pink, and my only other colors are green or pink, so those are my proportions. Green and green, pink and pink. When you have a proportion that is using the two smaller triangles, not the original, but the two smaller, and you're using both of these, you're going to see a neat effect called the geometric mean. So what happens is we're going to use this for this triangle, x and 2, 32 and x. You're always going to get the altitude going this way. So when you do the cross product, you end up with x squared. So you have x squared equals 2 times 32, so x squared is 64, which means x is 8. This number for that product is called the geometric mean. And it will also happen if, let's say I do a general case, and I'm just going to do the exact same colorings, all right? And I'm not really worried about the hypotenuse, so I'm just going to copy from here. And let's say I call this side A and that side B and keep this at the X that I'm looking for. This represents two numbers that I'm putting together, all right? So when you know both these numbers and you're looking for the altitude, all right? So you set up your proportion like before, green, green. So we have X and A, B and X. X squared equals A times B. So X is the square root of whatever A times B is. That is the geometric mean. Again, it's a nice little shortcut when you know both these numbers. So if I had, say some of my sides were 6 and 8, well, x squared would be 48. And so my answer would be the square root of 48. And you could simplify that radical. If I had 16 and 25, so my answer would be 400, right? So x squared is 400, so x would be 20. If I had 9 and 4, x squared would be 36, so x is 6. The geometric mean of 9 and 4 is 6. So it's a neat little term. It's not something that you'll run into in, say, when you're studying engineering too much or physics, but it is a cool little geometry tidbit. And it's a nice shortcut when you know you're just looking for the altitude and they gave you the two legs. It does not, if you need to do these two sides up here, we're talking about a different problem. But if you're just dealing with the altitude and the two legs there where they make the hypotenuse, geometric mean is a wonderful shortcut.